So if you see here, this is the example we're going to go through, and it's basically dex.stringhandler.com is a deployed instance, but you'll need a custom version of this Apogee um, extension to test it out, which is currently in PR. But yeah,
Nice.
this
I
is
don't
just
know
to
if you
show.
can make your font any larger. It looks a little bit tiny to me here.
Okay, well, I'll
If you
I'll
can't,
I'll
then
come. Yeah,
so be it.
yeah, yeah. I'm sure I can. Sure can. I can just make it smaller, and then that usually makes the window bigger. Otherwise, let's try and make it bigger that way. Okay, but basically, we'll come back to this now. I don't know if I can scroll here, but basically, what this is just a simple DEX that is a certain amount of TLBTC, and it's a swap for test, which is the asset you can get from the faucet, the testnet faucet. But basically, it's a USD kind of thing. But so the swap here is a single UTXO, which is basically a covenant that says the UTXO is on chain and has a covenant saying that I don't care who spends this UTXO, but the UTXO in that transaction, it has to have an amount which is equal to 12 USD going to my public key. All right. So that's so basically this website allows you to click make an offer. Let me see if I can make it a bigger. And if you click make an offer, then it will ask you to fill some stuff out, and then you can create it with the extension. We'll go through that. And then also you by paying 12 tests to this address. All right. Okay. All right. So let's just switch for a bit and I'll show you what this TX manifest is, which you'll be hearing a couple of things about. All right. So this is the covenant, the source code for the covenant that we're looking at over here, which is stringdex.symph. It's actually copied from Kaleidoscope, Kaleidoswap. They had a Tessera, which they called, it was Tessera.symph. It's basically their pattern that they had, but I've changed it a bit. It was part of the hackathon demo, but so that's the basic idea here is, and this is the flow that a developer would usually take. You would generally write the simplicity file and you've got most of it sorted out. You've worked out, okay, this is what the covenant works and stuff. But the next problem you have is how do I get wallets to integrate this now? And up until now, your main option has been that you would need to write your own custom wallet. And there's lots of libraries for helping that. There's the LWK, there's the um, Simplex. There's also, you could just write your own wallet and you could use the simplicity file. But what I wanted to try and achieve here was something that was uh, a dynamic representation of how to interact with this UTXO for wallets. And that's where this TX manifest come from. And it's basically just a standard that is a JSON format that describes what the different operations are that you can interact with. And using those operations, you link with one or many um, simplicity files. So in this case, I've got two simplicity files that I'm dealing with. The one is stringdex and the other one is make it payout, right? And in this case, we specify each one of the different methods. And inside of the methods, it has a bunch of parameters, and then it tells the wallet how to construct the transaction in order to interact with these things. So in this case, we've got the inputs, and it says it needs to have an input which is of the type the offer asset, which is, what we're going to be paying in to get it. And then what we're going to be locking up, in this case, we're going to be locking up the amount of BTC that we're going to put in there. and that comes from the wallet. And then it tells it what outputs to create. In this case, we need to create an output which has a UTXO type of string.dex offer, which is linked to this string.dex simplicity file with a couple of different options. And then there's all sorts of different outputs that are here that are needed. And that's the case for a lot of these protocols. There's a lot of extra outputs and the very specific pattern that these transactions need to take. So by making this a specification, a standard that wallets can understand, and we're hoping to publish a common library for different languages that allow wallets to integrate this very quickly, then they can use this to integrate dynamically without having to have custom programming for every single simplicity file that is out there. Okay, so let me come back here and show the demo. If I can just remember my password. Okay. Okay, so I hope it's not too small, but we'll start off with just creating an offer here. All right, and in this case, then when I click publish offer, this is obviously the website that I've created. It's going to dynamically send that TX manifest file along with the parameters and the action it wants to call to the extension. And then the extension will decide whether it wants to actually invoke this TX manifest offer. All right, so in this case here, the first thing we'll see, and I know it's very small, can't zoom this unfortunately, but it says that it's an unverified contract. And at some point we may want to put this into the metadata registry. We're just talking about that now, but you should only really be executing verified signed contracts, signed TX manifests in this, but I don't want to go into that. That's a bit out of scope for now. But there's a little bit of a description saying what it's going to do. There's some details going on here so you can see what it's actually going to do, and then approve and sign, and then that will send out the TX manifest. It'll send out construct a P set, and then the internals of the wallet will run and execute the sign the transaction and broadcast the transaction. You get this data that comes back, which will be used for future interactions with the TX manifest. So usually a lot of these protocols have like an initial entry point, and then we need to keep the parameters for future interactions with us. In this case, the website has an indexer running in the background, and the indexer will pick up the offer and then will display inside of here. So then the next time when we want to call fill to this offer, it will use those parameters that have been saved and allow the wallet to invoke it here. So we'll call fill offer here. And again, it'll tell us a little bit about what's going on. It's again another call to the same TX manifest, showing the inputs and the outputs. And then we approve and sign, it'll go and it'll broadcast that transaction. Alrighty, and that's filled. Okay, there's a couple of extra steps here, and that's why we don't see the balance coming back here. That's because the balances have been locked in that secondary script and haven't really got a claim for that yet at the moment. So, but that's the idea.